I don't want to draw this out any longer. You're not here for me, you're here for the awesome speakers that we have tonight. And it's my great pleasure to announce the first of them. He's the receiver of the Rails 2025 Luminary Award, which is a pretty big deal, I think. If you've been to any conferences in the past 2 years or so, you've probably seen him, you've met him. Right now, he's working on Herb and ReActionView, and he's going to tell us all about that, I think. Please, everybody, welcome Marco Roth.
Oops. Cool. Does this work? Awesome, awesome. So, hi everybody. My name is Marco, as Hans introduced me. Thank you so much. I'm super happy to be here today to talk to you about the stuff I've been up to with like my adventure with HTML+ERB. I have been focusing on making, or trying to make, the Rails view layer a better solution for people that want to build more ambitious apps in their Rails applications. So that's what I talk about today, kind of where we are at, what we are doing, and kind of how we get to this goal of having reactive rendering in Ruby and Rails web frameworks. So yeah, I've been trying to kind of push the boundaries of what's possible, and with these real-time server-side rendered web applications, using this novel HTML+ERB approach that we have been seeing coming back to the last few years. And more recently, I've been on this mission to improve, or try to improve the developer tooling and developer experience in that area specifically. And yeah, that's kind of where we get to ERB now, which, if you're not aware, is the abbreviation for embedded Ruby. And the thing is that ERB itself is versatile, so you can use it for pretty much anything you want. But most specifically in our apps, usually in our web applications, we use it with HTML around it. So we kind of have to look at this as HTML+ERB as a combination of things. And this talk is kind of a continuation from my previous talks at RubyKaigi, RailsConf, and Rails World last year, where at RubyKaigi last year, I have introduced this tool called Herb, which itself is kind of coming together from this HTML+ERB, which is kind of the abbreviation for Herb. And as part of this ecosystem, we have this parser now, which is in the middle of it. And that's where we launched this. So we had this parser with like these bindings for all these languages, including like Node.js and Ruby. The parser itself is written in C. You can also use it in the browser using WebAssembly. So it's just like super portable and super universal. And from that, we kind of grew pretty much a full complete tool chain for tooling that we can use in your apps today. But also in this talk, I kind of mentioned this idea of a new rendering engine that's kind of HTML+ERB aware. And that's what we want to talk about today, kind of how we get to this reactive rendering in our HTML+ERB engine. So for this, we need to talk about ERB engines itself. We want to talk about reactivity and what's still missing today. So let's start with Herb. The thing is about Rails is that it just keeps working. And an app you wrote a few years ago in Rails 5 still kind of works today if you upgrade to Rails 7, Rails 8. You don't have to rewrite the whole app. It just kind of keeps working, and you just have to upgrade Rails, and you get all the new latest features, nice things. So the challenge is always kind of how do you kind of innovate without breaking the existing tools and the existing apps, and without having to rewrite those. The other kind of thing we saw was this new wave of the Ruby developer experience improvements. I borrowed this slide from Stan Lowe. He kind of summarized the timeline of what's happening, or has been happening in the Ruby developer experience events since Ruby 3.0. And I also have this slide from him where he's kind of showing that the new Prism Ruby parser at the bottom is like powering all these tools built on top of it. Which now includes RuboCop, the Ruby LSP, and a lot of other tools that are, even like RDoc, that are all powered by this now. But we have kind of one spot where we haven't been really focusing on, which is the view layer itself. So I have been asking myself, why did the tooling for this kind of never existed before? And I think the reason for that is that there's nothing that we could have built on top of. So there was no parser like Prism now that we could use to build these tools for HTML+ERB specifically. So the question was more like, what would become possible if we turn or take our ERB engine and runtime and make it also aware of its HTML surroundings? And what if we established a more formal grammar of what HTML+ERB really means and what this is? A formal syntax to define kind of what's valid and what's invalid. So we can provide structure, hierarchy, and this HTML awareness that our tools and also the runtime can understand and reason about. And with Prism now, we have this other kind of missing puzzle piece. So we can take our HTML+ERB parser, we can take the Ruby Prism parser, and we can now have pretty much this full validation before we even try to run our code. So which means like if you have a missing end tag, or if you have invalid Ruby syntax or invalid HTML syntax, either Prism or HERB can catch those and kind of warn you about these things. And establishing this grammar is what makes this all possible. So what HERB really is in the end is like, it combines two things that never existed before. It defines the syntax of what the rules are and how HTML+ERB interleave, how they nest and how they relate to each other. And it defines the grammar of like what the structure looks like and what's allowed and what isn't, and what the engine, when it tries to run your code, can count on. And with a syntax and a grammar, you can build a parser, and with a parser, you can pretty much build this full tool chain for HTML+ERB. And that's kind of what was missing. Not just like these tools, but kind of the language definition of what HTML+ERB really itself is. And this also means that we have now one parser, we have one truth, which means your editor, your CLIs, your Rails apps all use the same parser, which means they have the same errors, the same trees, the same rules, so it all kind of shares this underlying architecture. And this is really powerful. So if your editor tells you there's an error in your code, you don't have to run it. It will tell you, and it's going to be right because it's using the same architecture. And that's kind of what we have been trying to do with this language server, which you can kind of install for any editor today that supports the language server protocol. And it just gives this instant feedback in your editor about syntax errors, about opening and closing tags that are missing, invalid syntax for HTML, invalid syntax for Ruby, powered by the Prism parser. And there are so many other things that it supports that I can talk about today. But it has the lint integration, it has the formatter, it has language like navigation tools, all kind of built in. This just works for ERB files too now. So this is what's all kind of about the tooling and like the stuff you can build on top of it. But now we want to kind of move towards the runtime section of where we actually want to render HTML using our ERB templates. And ERB templates in the end are also just Ruby, or well, almost, because we need to first convert our ERB into Ruby. So that means kind of we need to take our templates, pass them through the engine or a compiler, and then we get a Ruby code that your Ruby can actually run and render. And today, for most Rails apps, this means you are running eRuby engine. This is what Rails kind of defaults to today. And I want to kind of walk you through how this works today. So let's consider this template. And what eRuby does is that it uses a regex to match this template. And it slices it up into multiple pieces, like the static and the dynamic pieces of your template. And it represents them as like strings or dynamic Ruby code. And it goes through each of those and calls add text or add expression for the static and dynamic pieces. And it does this for each of these elements. And what you end up with is a sequence of instructions of how it has to compile this template. In this example, it kind of ends up as something like this, where you have a buffer at the end, which is a string. You shovel in the static pieces, and you run the Ruby codes and shovel in the result of that into the buffer. And at the very end, you call toString on it because you want to render a string as a result. This is designed to be evaled, so you can eval these codes, and at the end, you have the rendered HTML as the output. So this is kind of how we take our templates and turn them into rendered HTML content. But you also might have noticed that this template has like an error inside of it that is an invalid HTML tag, and eRuby didn't know about any of that, so it just happily compiled and rendered this anyway. And this is fine for most cases, but if you want to have accurate tooling, we cannot enough build stuff on top of that. So you want to make our engine aware of this HTML around it. And this is also what we need to be able to power this reactivity, so we can have similar tools to things like Phoenix LiveView or in Laravel, like the Livewire, what they have. And for us to be able to do that, we need to understand our HTML around it so we can build these features. So you want to take our ERB engine and make it an HTML ERB engine, or put differently, we want to go from string templating to HTML templating. And this is what Herb engine allows us to do, which is this eRuby compatible implementation of the same engine and same API. And when you try to compile a template, it will tell you if something is wrong about it and where it's wrong. So it will give you instant feedback about your templates. And as I mentioned, it's HTML aware. I can render the ERB. It's ERB engine API compatible. And let's take a look now of how we can do this time with a valid template and how Herb engine handles this now. So we can use the Herb parser to parse our templates. This will give us a syntax tree that looks like this. I will zoom in on that to kind of show that we have parsed a HTML element node. It has an open tag, it has a body, it has a close tag. And what we can do now with Herb itself is we can implement a visitor, which is kind of a implementation of this compiler that can compile our Ruby code that we can run in our runtime. So we can visit strategically all these nodes in the tree, and then for each of those, handle these nodes specifically. So for our HTML open tag node, you can see on the right side, we have the individual pieces of that. And since those are like strings, we can call add text as we were doing in Ruby before. For the content itself, we get a HTML text node, and since it's just text, we can just append that in the same way with add text. And more interestingly, for the ERB nodes, we can check what the opening tag is, if we are outputting or not. And depending if we are outputting, we call add expression, which is like just adding the expression to the outputs, or otherwise call add code, which is for things like if statements that don't need to have the output put to the buffer. And if you kind of go through this whole template and walk these all these instructions, you get this list of instructions. And if you compare this back to eRuby engine, you can see there's a lot more thing we are doing now. So there's a lot more instructions that we have to process. The one thing you can do now is we can do a optimization step. Instead of directly compiling the template, we collect these tokens and also register their type. So for a list of these instructions, we get an array of these tokens. And as you can see, there are a few consecutive text tokens. So we can take those, compact them into one individual text. And then for each of those elements in the array, we can then call add text or add expression again as you were doing before. And now if you come back to eRuby, it's pretty much the same instructions, so it's going to produce the same output, which is great. You can also see this in the compiled output, which is pretty much the same, except the eRuby and the Herb reference there. But with the benefits that we get all the guarantees that the Herb parser gives us, so we know it's valid HTML, it will produce valid HTML, and it's kind of we can build on that now. So we took it now from the string templating engine and made it a HTML templating engine. And with this knowledge, we can tackle more ambitious things now. One of the first things we did was to improve the error pages in the browser when you try to render a Rails template in the browser and you have a syntax error. Previously, it was kind of showing this big screen with the error message, and now it points you exactly where the error is and what's wrong about it. So this is kind of a good improvement already. And since we now also control the rendering itself, we can also do more ambitious things with like injecting additional markup in development. So you have more helpful debug tools when you work locally. And one thing we do by default now, if you install Herb, it will give you this debug menu in the top right corner, which allows you to enable these options. And if you kind of toggle the outlines, what it gives you is like these outlines around your views. So you can see where your views start, where they stop, and kind of where the boundaries are of those. And you can also see that there are different colors for the partials, for the components, for the actual views itself, so the blue and yellow and green. And you can hover over these labels, and it will show you the exact path in your app, kind of to see where they're coming from. And the other nice thing is that you can click on those, and it will bring you right to your editor to see where it's coming from. So it's like going back and forth between your files and the browser. The other thing we have is these outlines for the dynamic pieces where you are rendering ERB. So all the purple outlines are places where you're using ERB to output this content. And the nice thing is you can also hover over those, and it will show you what was used to render out this content in the browser. So again, this is really helpful to go back and forth between what you have rendered out and where it's coming from. So yeah, these are the tools, but how do we get from this to actually reactive rendering now? What else do we need? And I've been thinking about this more like, how could we complete this Hotwire story to kind of keep what Hotwire has and makes great, but make this additional things on top of it? And how would that look like? And like, what if Ruby apps could have all these nice features that the single-page applications promise to us, without us having to abandon server-side rendered HTML, and without having to write these single-page applications? So essentially, without having to give up full-stack Ruby, which is why we are using Ruby today. We want to kind of keep writing Ruby. So let's talk about reactivity. And if I talk about reactivity, I want to talk about two things, which is like the production reactivity that you deploy in your production system so that you can have interactive experiences, and local dev time reactivity that is more for tooling when you are working on your app. So let's start with production reactivity first. The reactivity landscape is kind of interesting because every major ecosystem has tackled it in some way or form. In JavaScript, we got React with virtual DOM diffing. Kind of it compares the whole tree and then only patches what actually changed when you kind of update the state. Svelte moved the whole analysis to compile time, which eliminates the whole runtime overheads that React has. And so it took it even a step further with this fine-grained reactivity they have with this concept of signals, which bypasses the whole tree completely and directly patches where stuff changed. So this is really kind of the three major ones in the JavaScript land. And then obviously we have the big counterpart in our server-side ecosystem, which is like Phoenix LiveView, and the Heeks and the EX engine, which kind of took this whole thing and makes it also compile time. So you can have this tracking when you are compiling the templates and have these slot level updates, and only set down the values over the wire that actually changed. And I think this is like the gold standard for server-side reactivity today, and kind of a lot of inspiration from what I'm working on today. And then also in PHP, we got something similar with Livewire, with Blade and Blaze. We've also has some DOM morphing capabilities, but it's not, yeah, it's also kind of an inspiration here. But the thing is that all these frameworks have something in common, which is that they all understand what they are rendering. They know about the HTML, and they have a graph of the dependencies to know what actually changed and what's in these templates. And this graph is what enables these fine-grained reactivity updates. And that's something we never really had in Ruby. And that's why I want to look beyond our own ecosystem and see what others do well, understand why it works for them, and then bring it back the Ruby way. So I looked at these frameworks and components and like libraries, and I want to bring this back to Ruby in the kind of overall theme, or like this kind of yeah, like this ReActionView experience. So the goal is that we kind of keep what's great, add what we are missing, so we don't have to use JavaScript frameworks to do the same thing. With the goal of making everything as backwards compatible as possible, so all our HTML we will use just keep working and get an upgrades pretty much like for free in a way. So the idea here, we kind of have our views, we have our templates, we have some kind of states. Whenever state changes, we look at what changed, and then we only render the parts that actually changed, and then try to send this to the clients, and then patch the client side to update to reflect these changes. But again, in order to do this, we need to understand what we are rendering, what's in the template, what control flow is being used, what state is available, how the data flows through your app, and the missing piece for those was obviously the two tools that I'm talking about today, which is the Prism parser and the RERB parser that can enable these things now. So how can we make reactivity happen? Today, like in a traditional Rails app, you do a request, the server processes it, and returns a full HTML response to the client. And on the server side, you kind of pass through the whole routes, it passes it to the controller, and then you render the corresponding templates for it. So you kind of have this whole sequence that you have to follow to know where stuff is going through. So the first challenge that we have to kind of overcome is we need to understand the render graph and what files are involved. So if you look at this profile show view from RubyVince, you can see that we have a bunch of render partial calls in here. So we want to understand what these partial calls are doing, and we can now use herb, luckily for us, to understand what is being rendered here. So it gives us all the information that we need, the partials, locals, and the names, and so on. This allows us now to kind of build this graph, and we can see what is being involved by, like, when you want to render this profile show page. So it shows you, here's profile show, and here are all the files that are involved to render this kind of page. And you can also kind of flip this around to say who is rendering this partial, and you get the other kind of site where you can see where it's all being rendered from. So you can see the whole trace of where this partial is being rendered from and where it's coming from. And since we have this full understanding of the views, you can also give you more diagnostics now. We can say, give us all the unused partials in our app, so we can see if there's anything left over that we don't need anymore. Or we can also see that we have some diagnostics about things you couldn't resolve statically for knowing which partial is being rendered. So we can show those here too. The second thing was to trace the state dependencies, which means that we want to know how things change and what needs to be updated as a result. And surprisingly, ERB is well suited for this, because every ERB tag itself has like a simple contract. And I can show you on this example here. So if you take this and mingle this up a bit to kind of compare it to the outputs, the compiled outputs, you can see that the items line is pretty much translated one-to-one to the right side. But the output tags, they get prepended with this underscore buff, the shovel operator, and call toString on them. So if you kind of look at this, the contract is whenever we are doing a interpolation, we are calling toString on it and shovel this into the buffer. And in the end, we don't really care about what's inside of those. We just care about that there's something being interpolated at this point. So it takes some state in, and it produces some state as a result. And the same is true for when you're rendering an ERB templates. What you get back from this rendering operation is a string as well. And that kind of basic idea is what allows us to build reactivity. Which also leads us to the next challenge, that we need to know which are local variables, which are helpers, and what they are doing in our views. So if you have these references, you need to understand what is user, what is linked to, where's user path coming from. So are those locals, are those path helpers, where are they coming from, what are they doing? And luckily for us, we can use Prism to do that too, to find locals. It can have its own analysis and can tell us in some instances if those are locals, if they're coming from somewhere else. And the other thing we had to build in order to know all these things is a registry of all the ReActionView tag helpers, to know which methods exist by default and what we can count on that it's actually resolved, that we know what it's doing. So the idea is we take all the references in our app that we are doing for like the rendering, and then subtract the strict locals, the path helpers, and everything else that are helpers. And everything that's kind of left over that we need to resolve and kind of fix for us to be able to do reactivity. At this point, it's just static analysis, so it's kind of an approximation. And for us to be able to do reactivity, you need to be able to understand all these references. But the good news is that this can be gradual and on a per route basis, so you don't have to do it on all pages at one time, but just on those that you want to have this more advanced reactivity. Yeah, just on the pages where you want to have this high interaction, high reactivity. And for these unresolved references, we can show you warnings, and this is what we can do with this new ReActionView command in the herb CLI. So you can give it any partial, it will tell you, here are the locals that are being used. You can see the locals it receives from all its dependency from this graph. And you can also see which helpers that it's being used from ReActionView and that they detected those. We can now run this on all templates and add a CI check for this to make sure that all of these are always resolved. And for the ones we couldn't resolve, we can show you warnings and show you why they couldn't be resolved and what they are about. In order to resolve those, you could either define these strict locals in the partials, or we might be able to have another way of explicitly declaring what they are doing. But the beautiful thing is now that we can use our own herb tooling to be able to tell you about all these unresolved references, so which is kind of neat. The fourth challenge was ReActionView tag helpers, which is, I think, the biggest one that we have to figure out, because if you take this template, there's a lot of ERB in here, and we don't really know about the HTML part of what's being used and done here. So if we want to change, or if post changes, what do we need to re-render in this case, right? So you can see post is being used in 3 places here. So you can see on the first line and this third line. But if you remember from earlier, we have a simple contract of saying whenever there's something inside of it, we don't have to care about it, but we just care about the string results. So if you take our first reference here, we have to evaluate to say, well, it's pretty much this whole tag here at the top. But since it's using a block, we also have to consider the ends, and then as a result, we also have to consider all its children to be able to figure out what's actually changing. So we end up re-rendering the whole template anyway, which is not ideal. So that's why we kind of added support to HERB now to be able to detect these tag helpers itself. So we can statically analyze the templates and then transform it to something that looks like this here, which is all the equivalents that would be rendered kind of partially evaluating this statically as in the parser itself. And if you look at this now where post is being used, we can see it's only being used actually in these 2 attributes, and there's the content of this A tag. And now we can much more reasonably argue about where we need to change these things and not have to re-evaluate the whole template every time we change a post. So this is kind of allowing this fine-grained reactivity as a concept. And a nice side effect of this is that also our dev tooling now gets smarter, because if you hover over any of these tag helpers in your templates or in your editor, it will show you the equivalent of what this looks like when it would be rendered eventually, which is also nice for going back and forth and figuring out what's actually being used and rendered here. Then we had one more challenge, which was to track the affected DOM nodes whenever you update a state. And what we want to build here is this reverse dependency index kind of. So let's take this example here, where we also have a post again. And you can see post is being used in these places. But for us, in order to update this post title, we need to know it's enclosed in this h1 tag. So we can actually write some operation to say, please replace the content of this h1 tag as a result. So we need to be able to target some HTML element that we can target it from the backend side using a selector. So we built this index now to tell you, well, if you see post in this template, it's using, or it has to also look at all these other nodes in the template. And with that, we are able to kind of compute the minimum amount of changes that we need to update the UI and reflect these changes. That's kind of where we are today. We have all these kind of static analysis tools now for knowing about the ReActionView tag helpers, about the strict locals, about this render graph and all the locals that are being passed through the render calls, and all these references in your view files. You can understand the render graph, you can trace these dependencies, you can resolve these action tag helpers, and it also knows now which DOM nodes need to be affected whenever something changes in the template. But yeah, we aren't quite there yet, so this is kind of the foundation that we have now to build on top of this. But this gives us all the primitives to make this vision happen now. So we need to wire up all these foundational pieces, and then we can have something like Phoenix LiveView in server-side reactivity for Ruby, which is under this umbrella of this ReActionView initiative. That's where we are today. So this is kind of check the future for updates here. That's what we are working on today. And the other thing I wanted to talk about in the same realm is like the dev time reactivity. The inspiration here was also coming from JavaScript with the Vite dev server, the Webpack dev server, where whenever you update a file in your code base, it will instantly update the client, the browser, and without having to re-render the whole page every time you kind of do that, or manually refresh your browser to see the changes. And for this, we built a syntax diffing engine for the syntax tree to know if you give it a old source and a new source, it can tell you which AST nodes kind of change between those two. If you want to check out the PR, it's actually quite interesting. A lot of technical engineering went into this, so you can check it out here. But the idea is that you can give it a nodes or templates and give it another template, and the engine is able to tell you what changed and how it changed. In this case, text changed. Or if you add attributes to a element, it can tell you that just an attribute was added and not anything else. So it knows about the semantics and everything about these templates and can tell you what actually changed. And this also works for all the other elements in HTML and all the ERB and all of that. So it can reason about what actually is changing between you saving the file. And now you might be able to see where this is going. We want to have a herb dev server, so you can actually run your ERB files, change them, update them, and have them reflect in the browser. So this is kind of the hot reloading in development. The idea is you run herb dev, and I can show this here. You run it, and it will kind of take all your files, it will index them, and once it's ready, it will open this WebSocket connection on a port, which is then ready to watch for changes locally. Under the hood is using this herb diff API I just showed you to compare between the old and new version. So whenever you update something in the content of your templates, it will detect what changed and logs it to the output here. And this is now kind of the CLI, but also if you now add this as a process to your proc file, for example, and you have the dev tools installed, you can see that it's now connecting to this WebSocket in the browser. So the dev tools in your browser are now connected to this web server or the dev server. So whenever you go and update your templates, it will instantly update the browser as a result. And this works for anything that is like HTML. And if it's seeing that you are using or updating ERB, it will do a smart refresh without having to reload the whole page. This also works for partials. So whenever you update partials, it will update all instances on the same page, so you can see how this is affecting your design when you update templates. And the same thing we can now do for the error messages. So whenever you have a invalid syntax in your templates, it will also show you these screens. When you fix them, they go right away, so you can kind of iterate really quickly. Or have your agents iterate really quickly, so you can see what they're doing. But yeah, the idea is there's no full page refresh. You just get these incremental updates by the diff engine, and that's kind of what we have for dev time reactivity. But yeah, to conclude, I hope this has given you an overview of what Herb is doing today, what it can do, and where it could be going, and how we might be eventually be able to achieve this full reactivity for production with ERB. The Prism parse itself had a big effect on the Ruby internals and the Ruby tooling landscape, and I think that Herb can have a similar effect for HTML templating and tooling. And just a few weeks ago, we got the news that also GitHub adopted Herb in their monolith. So they have over 10,000 view files that are now processing and checking on every commit with Herb to make sure that they are complying. So this is like a big win for the project to see it's kind of being adopted by big companies using ERB today. So this is really exciting. But yeah, so that's what we have. We have this new release, which is the Herb 0.10. It ships with all the features that I talked about today, including this Herb diffing engine, this Herb dev server, even some compile time optimizations, which I haven't talked about today, but there's a lot more in this release, including this render graph analysis and so on. And yeah, as I mentioned, I think that this is now, this like whole tool chain is now proving that there's some reactivity possible as a result. So I think this is kind of what was missing as the missing piece for the Hotwire story to complete it. So you can keep writing Ruby and build more ambitious web applications with even less complexity. And with these primitives, I am hopeful that we can achieve that. Finally, some acknowledgements. I want to thank everybody who has been reporting issues and trying out Herb. I want to give a big thanks to all the contributors, which some of them are here today. Thank you so much. And I also want to give a thanks to all the sponsors over the last few years that have been supporting my work on GitHub as well. And then finally, I want to give a thanks to the GEM Fellowship Program from GEM Co-op, which allowed me to work on these reactivity features as part of their grant from this year. So yeah, please try the tools, report any issues you might see, and give feedback. If you haven't already, give it a star on GitHub, and check out the docs on herbtools.dev. That's all I have today. Thank you so much. Thank you.
Thank you so much, Marco.